All right, so here's our lesson 4.3 on solving linear and quadratic systems. So the only systems of equations you all have ever solved before has been two linears. So for example, you might have, you'd have a graph given, and you did this in your must know, right? You'd have one line that went this way, and maybe the other line kind of goes the same way, but you're looking for this point where they intersect, and that's like your solution, is that point of intersection. And so I'll go ahead and write those notes down. Solutions to systems are point of intersection. They're named as x comma y because we're naming like the actual point where they overlap. And if you remember from Algebra 1, there are a few different options when we talk about lines. So for example, if you have two lines, they could either intersect in one point like what we've seen just there, or they could be maybe parallel to each other. That would give you no solution because there's no points of intersection. And the other one that you all learned in Algebra 1 was 2 points that coincide or they're right on top of each other, and we would used to call that infinite solutions. I guess you still do call that infinite solutions. That's because they're intersecting in an infinite number of points, right? Like everywhere on the line is intersecting. So today we're going to be talking about systems of quadratics and linear. So it's not going to have two straight lines. We're going to have one parabola and one straight line. So there's like three different options here. So we're thinking about how a parabola, and I'll kind of zoom up so you can see that. The idea is to think about how can a parabola and a straight line intersect. So we could have this parabola and a straight line just going straight through it. And that would have 2 points of intersection. So that would have two solutions. All right, or we could have this parabola, and this line could be tangent, if you remember that from geometry, just that it's touching in one single point. So that's going to be 1 point of intersection. And then the last option would be you could have this parabola and the line's not going to be touching it at all. So it's not that they're parallel, but they're just never really going to intersect. So that's going to be 0 points of intersection. All right, so we're going to look at two methods, graphing and then some algebra to solve these. So let's look at both of those. All right, so because we're doing an example on graphing, you should have a graph in your notes for tomorrow. All right, my hope is really to only do one of these examples. I'll only do the other one if for some reason I feel like we're not getting it. Maybe we'll do that one together tomorrow in class. All right, so let's go ahead and look at this first graphing example. It says solve by graphing, which means I need to graph both of these things. And you all know, you remember to graph, we obviously need these equations to say y equals. So that first one, another way to say that would be like y equals negative 3x. So if we're graphing that, that's just slope-intercept form, right? There is no plus b, so that means I'm going to start at 0. And it says my slope is negative 3, so I'm going to go down 3 to the right 1. And in these, it's kind of annoying, but you should probably put as many points as you can on the graph. It's just going to make it easier to find your solution. And then the other option is to go up 3 into the left 1. So I make as many points as I can that will fit on this graph. And then we're going to connect those. Wow. All right, my line's looking a little rough, but that's why making the points is so important. And then this other one is going to be, let's solve that for y. Y equals negative 3x squared plus 6. So this one, because it's got x squared, I know that means it's going to be a parabola shape. So I need to be thinking about my like dance moves there, right? So inside's the opposite, which means my vertex is going to be at 0, 6. And then outside, this negative 3 out here on the outside, that's going to be like my rise over run, which means instead of doing 1, 3, 5, 7 over 1, negative 3 is on the outside, so that's going to multiply these top numbers by negative 3. So let me go ahead and do that graphing. I'm going to go to 0, 6. It's my vertex. And I'm going to use that slope pattern, which means I'm going to go down 3 over 1 on both sides. And the next step is going to be negative 3 times 3, so down 9 over 1. And then if I had room to go, the next one would be down 15. And I'm actually already out of room, so those are the only points I can fit on there. So I'm going to plot those. I'm doing my best to make this look like a U, but it's kind of hard to make it look curved. And now we're just looking, solutions, we're looking for those points of intersection. So I see 2 here. One's right there and one's right there. So we're just going to name those solutions as the ordered pairs they are. So the first solution I see is negative 3, 1, negative 3, 1. And the other solution I see is going to be positive 2, negative 6. All right. So that's an example of how to solve those using graphing. All right, so the second method is how to solve using algebra. And sometimes, well, let me show you why this example probably wouldn't be the best for solving using graphing. First of all, this is 1/4 on the outside, which is not impossible, but it's kind of hard to go like up a fourth and up 3/4. Like it's just going to get really difficult to count and get exact points. So that is one thing that would make this difficult. The other one, if we go ahead and solve this second equation for y like we normally would, all right, I'm going to subtract 3x. That's going to give me negative 2y equals negative 3x plus 13. And then divide by negative 2. That's going to give me y equals negative 3 over negative 2 doesn't like simplify really, but the negatives can cancel. So 3 over 2x minus, we can keep that as 13 over 2 if we want. Even if you change that to 6.5, that's kind of difficult to graph to start at 6.5 and then go up 3 and like 3 over 2. So because that's tricky to graph, this is a better option to do for algebra. So what we're going to do, our kind of idea for algebra is to set y equal to y. So what I mean by that is this first equation says y equals, and now this one does, which means everything on the other side should be equal to each other as well. All right, so we're going to say this is 1/4 x minus 3 squared equals 3/2 x minus 13 over 2. So the first thing that you all might be like stressing out about is those fractions in there. So we're going to multiply by the highest denominator to try to eliminate those. So I'm going to multiply both sides by 4. We're going to see what that does. So on this left side, that's going to cancel. All right, so that's going to give me just x minus 3 really, because 1 times that's the same, x minus 3 squared. On the other side, we can kind of do some mental multiplication. So 3 times 4 is 12, and 12 divided by 2 is going to be 6, so that's 6x. And then 13 times 4, that's 52 if anybody plays cards. And then divided by 2 is going to be 26, so this is minus 26. Now, one thing that's really kind of obnoxious right here is you've got like this x squared over here and an x over there, so we can't really take square roots like we would want to. So one thing we are going to have to do is we're going to have to work this out. And by work that out, I mean you have to write x minus 3 times x minus 3 and do your multiplication, right, where you like double distribute. All right, so I'm going to kind of pause the video and go ahead and do that part for us. If you want to pause and try that part on your own, you can. All right, and now we're to a point where hopefully you notice you've got x squared, but you've got some of these other like x values as well. So we can't do square roots. This is going to be something that we're probably either going to do factoring or quadratic formula, just depending on what makes sense. So the first thing I know I need to do is I need to get this equal to 0. So I'm going to start moving some stuff over so I can make that happen. I'm going to subtract 6x. So I've got x squared. I already have negative 3 and negative 3. And if I minus 6 from that, that's going to give me negative 12x. And then I'm going to add 26 also. And let's see, 9 plus 26 is going to give me positive 35. So if I can, I'm going to try to factor. So I'm going to check that out. 35 is my top number. Negative 12 is my bottom number. All right, I think negative 7 and negative 5. Yeah, that'll work. All right, so I'm going to use that to factor. That's pretty nice. X minus 7, x minus 5 equals 0. We're back to that 0 product property. So that tells me that x equals 7 and x equals 5. Now the difference here between just solving like a quadratic and then what we've done before is this is just the x component of our ordered pairs. I need like ordered pairs, so I need the y values. So the last step is to plug these values back in. And we can do that using either equation. I think I'm going to use like one of each just to show you that it doesn't matter which one you use. So I'm going to plug the 7 in the first equation. So that's going to be y equals 1/4 times 7 minus 3 squared. All right, 7 minus 3 is 4. So that's 1/4 times 4 squared. That's 1/4 times 16, and 1/4 of 16 is 4, which means that first solution is 7 because that's the x value I just found, and 4 because that's the y value that goes with it. All right, let's try, I actually think I'm going to try the 5 in that one too because I don't really want to deal with the fractions in the other one if you want me to be honest. All right, so let's do y equals 1/4 times 5 minus 3 squared. It's 1/4 times 2 squared. 2 squared is 4. So 1/4 times 4, that's just 1. So that means this other ordered pair is 5, 1. So those would have been really messy to graph. And I know this algebra looks like it's pretty messy, but you get nice answers doing it this way with the algebra where, and if you had graphed, I think you probably would have been more likely to make some mistakes. So make sure you have both of those examples in your notes and you're ready for tomorrow.